All right, I did promise you in the previous lesson, which was EIGRP, both version 4 and version 6, that we're going to do another type lab where you're going to have several pathways that the packet can get to. So I want to show you how we're going to manipulate those two key, or really just one key value of the K values, all right, which is the bandwidth. All right, so let me show you exactly what's going on in the topology table, because now there will be a feasible successor, all right, because you have two different ways it can go. So you can maybe better understand what you're looking at, because the other one was just straight across. There was no feasible successor, and everything had pretty much the same metric. So let's take a look, because remember, we got two destination networks. We got the 100.0 and we got the 200.0. As you notice down here, you have 3 routers versus 2 routers up here. All right, so let's take a look at router zeros. One click. And again, if I'm in the way, I'll get out the way after I do the command. It's enable, you know that, config T. And we'll do a show IP route. Show IP. Now roux, that's in French, by the way. No. I'm in the wrong place. Show IP route. Okay, as you can see here, show IP route and the routing table that we have to get to the 200 network, we're going via the 10116, which is up, all right, through the serial 000. That's what the routing table is saying. Take a look at this number right here. Remember, this is the feasible distance. This is the successor route, all right, the 268-6976. So but there's 2 ways that it can go. Let's take a look at the topology table. Remember, we only got one way to get there, according to the routing table. Let's take a look at the topology table. Show IP, EIGRP, topology. Topology. And if you look for that same destination network, let's move it up a little bit here. Right here, everything is passive. Remember, we said it was good, but we have 2 ways. We have the 6 and we have 29. 29 is coming down. But if you take a look, this is the number that we saw up there. Well, this number is lower than this number right here. Therefore, it will use the feasible distance, which is the 268-6976. That is the fastest route. That is the best route to get to that point. Why is that the best route? Think about this, just to do our little math in our head. Nothing big, nothing major. Don't freak out. All right, let's take a look. Well, you know already because I've shown you, right? These are WIG2Ts. Both of these are 1544 megabits per second. The fast Ethernets, though, let's take a look up here, and I'll show you those. Enable, show interface F0/0, right? And we look at its bandwidth. Let's just maximize the screen. If you take a look at its bandwidth, is 100,000 kilobits per second, which is 100 megabits per second. So think about just that bandwidth right there, and the delay is 100. But when you're doing the calculations, not you, but EIGRP, it's looking that you have 2 routers, so you have a delay. What will be the delay over here? I think it's 20,000, which turns out to be is it 20,000? Let's take a look at it. I forget. Just want to make sure that I'm telling you the right stuff. Show IP, no, not show IP int. Show interface, not UBT. Show interface as 0/0/0. It's a delay of 20,000, okay, which really turns into 2,000, but 20,000. And we have 100. But here you only have 2, right? Here you have 3. So you're going to have a bigger delay going this way than you would going this way, because it's cumulative delay. So you'll have more delay coming this way than you would going this way. That's why EIGRP chose to send the packet that way. And let's verify that the packet does go that way. So what we're going to do is we're going to go to simulation mode. Simulation mode, okay? And we're going to choose the closed envelope, which is a simple PDU, a ping. We're going to click on it. We're going to click on PC0, and then we're going to click on PC1. Yes, you're not going to see an arc because I did this lab. I pinged across to make sure we had connectivity. That's why you only see the ping now. So if I were to auto capture and play, you see that it's going to go up. And we'll wait for the little envelope. There you go. Goes up because it's chosen. The routing table says it chooses to go that way. Because again, the delay this way is a lot more than it would be going this way. So we're going to actually tweak that, manipulate by changing the bandwidth of the path. I'm actually going to change the bandwidth, or we're going to change the bandwidth going across each side because we want it to go that way and come back this way. That's exactly what we wanted. We want to do the opposite. Since it's coming this way and coming back this way, we want to send it down this way. So we're going to increase to the maximum amount of bandwidth, which is like 10 million. All right, we're going to, yes, I do exaggerate. Because that's just me. You should know me by now. All right. We're going to go ahead and do that. We're going to go ahead and increase the bandwidth here to every point along here. We're going to increase it to 10 million. All right. And then this way, we're going to reduce it. I'm going to put 100. Or I'm going to put 64, 64, 64, 64, 64, 64. I'm just going to go to the two extremes. And you're going to see how EIGRP is going to recalculate. And then what it should happen is that the packet now, the routing tables will change. And it should tell you that it's going to go this way. So let's get that done. So I'm going to go to the first router. And this is pretty simple. All you got to do, let me bring it this way so you can, all you do is you go into the interface and you change the bandwidth. Now we're going to change the bandwidth first going down. So that's my S001 and then S00, we'll look at the routers as we do them. Okay, so first my S001. Let's do the bottom first because I get very easily confused. Config T, interface S0/0/1. And let me open it up a little bit so you can see a little more. And we're going to do bandwidth. And what did I say? 64. No, that's 10 million this way. 10, 1, 2, 3, 1, 2, 3. So we're changing the bandwidth to 10 million. Boom. And you see it starts, now the bandwidths are changing. Your EIGRP is going, hey, what's going on? Right? And going up, well, I said we first going to do the ones going down. Okay. Then we'll do the ones going up. So we did that S001 here. We changed the bandwidth to 10 million. Now we got to do these two right here. We're going to put it to 10 million. Because I want to make sure that it chooses that route. So S000 and F01. Okay. And make sure you guys can see that. So enable config T. Was that S000? Yes, it was. Interface S0/0/0. Bandwidth 1, 2, 3. 1, 2, no, 10. 1, 2, 3, 1, 2, 3. Cool. And then the F01 int F0/1. Bandwidth 10. 1, 2, 3, 1, 2, 3. So we'll do WR. All right, let's minimize that. That was these two. Okay, now we're going to do F00 and F01. 10 million both. Down here. Because remember, we're going to manipulate the bandwidth in order for it to make it go the way we want to go. Because bandwidth is a variable. It's a logical variable that we can manipulate. We can't manipulate the delay, but we can manipulate the bandwidth. Config T. Int F0/0. Bandwidth 10 million. 10. 1, 2, 3. 1, 2, 3. An up arrow. F01. Up arrow. Boom. Done deal with that one. Do WR. Then I'm going to go to this router right here, which is the F00 and S00. You can see right here. These two right here. 10 million here, 10 million here, and then the last one will be 10 million right there. That will finish everything off. So all zeros here. So let's go ahead and change that. And let's move it this way so you guys can see it. Okay. Right there. enable conf t, interface f0/0, bandwidth 10 million, oops, 10, 123, 123. Okay, and then the int s000. Type it again just in case, because I hate when it interrupts the typing, so I do it again. And then I'm going to put the bandwidth of 10 million. Awesome. Do WR. And then in this last router, we're just going to do that S001. That's it. That will be the last one we do as far as 10 million. Okay. Enable config t, int. Let me move it this way so you can see what I'm doing. Int S001, 0/0/1. Bandwidth 10, 123, 123. Do WR. All right, remember, you guys can't do WR. You guys got to go back to privilege mode and do copy, run, start, enter to do your stuff on the test. You can't do the do and all the tabs and stuff that I do. I just do it for the sake of time. Now, what we're going to do, now we got from this point all the way around to that point, the bandwidth for each of these interfaces has changed to 10 million. Now, I should now pick, I mean, we could really, let's see if if we don't have to even bother with the top, if we can just leave it alone so we don't have to go around again. Show IP route. It should have changed already, and you see that it did. So good. We don't have to change the top. I mean, because the top is 1.544 or 100. So we've really increased the bandwidth on the bottom quite a bit. So you can see it's already pointing before. Okay, before it wasn't pointing to 29, it was pointing to 6. So now it's pointing to 29, meaning it's going down. Take a look at the metric. It has changed. It has changed completely. It recalculated everything. Let's take a look at the routing table. Or the topology table, I'm sorry. The topology table for the 200. Oh, look at that. The 200 only has one way to go. One way to go, which is that way. It doesn't, you don't see any other way to go to the 200 but that 10.1129. Since the bandwidth is so spread apart, remember I said that the feasible successor has to qualify. Has to qualify. In this one, it couldn't qualify because I used too much of an extreme. There was no way that the advertised distance of one of the routers can compare to the feasible successor's feasible distance. So there is no feasible successors. So let's take a look and see what happens. So cool. We don't have to. And let's take a look at this routing table because we never have. We haven't done that yet. Let's see what this guy says. Control Z. Let's take a look at the routing table. Show IP route. All right. And we got the 200. I mean, we're trying to go to the 100 and it says it's going via the 1118. The 1118. And where's the 1118? It's going down this way. So once it hits this, it's going to come back down that way. All right. Let's take a look at the topology table. Show. Okay. Show IP EIGRP topology. And we're looking for the 100 network. And there it is right here. The 100 network. Let's raise it up a little bit more so you guys can see that. Here's a 100 network. There's only one way to go. There is no feasible successor. There is no, it didn't qualify. So you have no backup route. So what's going to happen? Will there be a problem? The only problem in this case is since there is no feasible successor, so it can't query the topology table to just choose another route to get to. What's going to do is going to have to do an update all the way across. It's going to have to recalculate the whole thing and then find how to get to the 100 network. That will be the bad thing. Other than that, that's it. And the calculation is really quick. It's not as bad as OSPF. Only those routers will calculate that particular route and say, hey, okay, this is how you get to this particular area. Only that one router, not every router. So you can see there's only one way to get to that 100 network or one way to get to the 200 network. right? Which is going down, not coming up. It's not going through the top route, it's going through the bottom route because we manipulated the bandwidth. Now, since I took it to an extreme, I took it to a point where the feasible successor could not qualify. All right, so let's see what's going to happen. Let's see if our calculations are correct. All right, so we go to simulation mode. Once again, we take our simple PDU. We click on the PC0. Remember, last time it took up, it went up. Now it's going to go down. Let's do auto capture and play. Sit back and enjoy the fun. Let's see the movie. There's your ping. Vroom. Straight down. Okay. Slow. And it's 10 million. It's still going slow. All right. Ether channel, right? No. It's going across the wide area network here, supposedly. All right. Come on. Now it goes there, goes to the PC, and it should come back the same way. It should come back the same way. This is just showing you that bandwidth is actually something that we can manipulate. So when you're doing EIGRP, these are ways that you can tweak it to make the packet go the way you want it to go. And it is. It is. We changed it. So now it's going the way that we actually told it to based on bandwidth. So there you go. That's what I wanted to show you. Not only did I show you that you can tweak it by changing the bandwidth, and I changed it just on one side to obviously an extreme, but I changed it, but as well that, hey, there was no feasible successor because it couldn't qualify. It couldn't qualify. And now if one of these links goes down, then it would actually have to recalculate those routers. Oh my God, let me send out again updates to find out it goes active and say, hey, I need to find where is a way to get to the 200. So a lot of math needs to happen at that point to find the whole thing. If there was a feasible successor, all they had to do was query the topology table, and then we choose from there. So again, it's all based on how you set up your network, and if you are going to mess around with the bandwidth, how far do you go? But again, that's beyond the CCNA. All you need to be concerned about is that, hey, bandwidth is what we can change. There you go. Now you're really seeing every part of EIGRP that you need to know to pass that cert. I'll see you in the next lecture.